Hello everyone, welcome to 3.2b, the second half of section 3.2. 3.2a talked about implicit differentiation. 3.2b we're going to talk about the derivatives of inverse, and that includes inverse trig functions. Well, let's go back. What are inverses? Those of you that had me for Algebra 2, I tried to stress this to you. What makes an inverse? Switch x and y. The inverse of a function is written f negative 1x. That's not f to the negative first power or 1 over. That means the inverse of f of x. Remember, switch x and y. They're inverses if they cancel each other out or if they reflect over the line y equals x. Inverses have derivatives too. That's f inverse prime. Well, let's talk about inverse derivatives. Remember, a derivative is the same thing as a slope. And a slope is y over x. But if I want to do an inverse derivative, remember, inverses mean switch x and y. So that's just x over y. What am I trying to say here? The derivative of the original is equal to the inverse of the derivative. The derivative of the original is the reciprocal of the derivative of the inverse. So if I know the derivative of the original is 6, that's 1/6. If I know the derivative of the original is 1/4, then that's 4. And that's how we're going to do these problems. We're going to find the derivative of the original and then just flip it. What about a problem like this? I can't switch x and y in this problem. Why? Because I would have x equals y cubed plus 3y squared plus 5y minus 9. Now you can do implicit differentiation if you want to, but it's a mess. We can do the derivative at a specific point though. Let's take a look at this problem. I want the derivative of the inverse of the function at 6. Side note, historically this section has always been tricky for people. That's why I made an extra set of notes for a mini lesson that you can find on YouTube. There's an entire mini lesson dedicated just to this idea. But how do I do it? Well, remember, this is an inverse function. So like this would normally be an x value. But in this case, 6 is not an x value. It's an inverse function. So this means that y equals 6. So I need to go through and find an x value that corresponds to y equals 6. So I'm going to plug this problem into my calculator. Yes, you need a calculator to be able to do these problems. That's my equation. Let's look at the table. Where on the table does y equal 6? Right here. So now I know that I'm looking for f of 3. The point is 3, 6. Since 6 is the y value, and I know that because it's an inverse, I know the x value is 3. Once you know the x value, we're going to take the derivative, plug in the x value to find the slope, and then the derivative of the inverse is the reciprocal of the derivative of the original. So let's say that again. In fact, let's just do this problem. I want to find a derivative. Let's find the derivative. F prime equals 3x squared minus 6x plus 5. But what number am I going to plug in? I'm not going to plug in 6 because 6 is the y value. I'm going to plug in 3 because 3 is the x value that goes along with 6. I got that from the calculator. That's 27 minus 18 plus 5. That's 27 minus 18 is 9. 9 plus 5 is 14. Now we know that the inverse derivative is the reciprocal of the original derivative. So what's that make the answer in this problem? Since the original derivative, sorry, I forgot my derivative sign here. Since the original derivative was 14, the inverse derivative is 1/14. It's complicated because of the relationship with the x and the y. Remember, they give you a y value. So when you take the derivative of the original, you can't plug in the y value. You have to plug in the x. Once you get your derivative, flip it and make it the reciprocal. That's the inverse derivative. Okay? Again, there's more practice problems out there in a mini lesson on YouTube. Go find it. Inverse trig functions. Well, just like any inverse, you can create inverse trig functions by switching them. There's two ways to do this. Last year you guys probably talked about sine inverse. That's second sine on your calculator. A long time ago we used to say arc sine. A lot of old trig books say arc sine, arc cosine, arc tangent, arc secant. They mean the same thing. I normally will say arc sine as opposed to sine inverse. I just think arc sine looks better. But be able to do both because the AP test has both of them on it. I just need you to memorize these 6 inverse trig functions. These are the last, no, a lot. This is almost the last set of derivatives that you have to memorize. And if you notice, they're pretty easy. You only really need to memorize the left side because the right side is the same thing, just negative. They all have a du dx at the end of it. That's because of the chain rule. And you'll see an example in a second. I want the derivative of arc sine of 2x. This is a chain rule. Why is it a chain rule? Because the outside is arc sine and the inside is 2x. So, let's take the derivative of the outside. The derivative of arc sine. 1 over the square root of 1 minus the inside squared. That took care of the arc sine, the outside. So I've got that taken care of. Now what do I have to take the derivative of? The inside. What is the derivative of 2x? It's just 2. Now I took care of the derivative of the inside. Don't leave a problem like that. Clean it up. That's 2 on top, square root of 1 minus 4x squared. If you know the 6 formulas, they're really easy problems. Just don't forget your chain rule. Arctan of 3x. Again, this is a chain rule. Why is this a chain rule? Because it's got an outside of arctan, and it's got an inside of 3x. So I have to do this as a chain rule. Well, I have to know what the derivative of arctan is. The derivative of arctan is 1 over 1 plus u squared, or 1 over 1 plus the inside squared. That took care of the derivative of arctan. Now let's take care of the derivative of the inside. What is the derivative of the inside? It's just 3. Don't leave the answer like that. Clean it up. So that's 3 over 1 plus 9x squared. Okay? What about this one? This is still a chain rule. The outside is arc sine, but the inside, in this case, is x to the 1/2, or square root of x. Let's take care of the outside first. Derivative of arc sine is 1 over square root of 1 minus the inside squared. So I took care of arc sine. Now let's take care of the derivative of the inside. What's the derivative of x to the 1/2? It's 1/2 x to the negative 1/2. That's the derivative. Calculus is over. Now let's do some cleanup. Well, I know this problem is going to have a 1/2 in it. This is going to be the square root of 1 minus x. And this is going to be the square root of x. You can leave your answer like that if you want to, or you can write it like this. Either way is fine. I like the second one better. Okay? Basically, all you have to do for inverse trig is memorize those 6 inverse trig functions. The inverse functions, though, are a lot more difficult. Again, there's a mini lesson out there for you to watch if you have more trouble. As always, if you have questions, we're going to go over it in class. I'm here before school, after school, or during study hall. Thanks, everyone.